Okay, the last concept over here in vector 3 we'll be learning is actually finding the distance between two parallel planes. Okay, take note, the reason why I actually place it inside these notes is because over the last few years, we do see the trend of this question being appear a lot of times. Okay, be it from prelim papers, school exams, to even A levels as well. Okay, so we have to sort of learn this because a lot of things we can actually derive from this, and a lot of application kind of questions are actually appearing in relationship to these two concepts, or rather to this concept. Okay, so to find distance between two parallel plane, there are actually a few ways to actually learn how to find it. Okay, so I'm going to go through with you the fair bit of different kinds of methods to actually find the distance between two parallel plane. And over here, you should be able to find something that suits you the most. Okay, now let's quickly just draw out. Let's say this is my plane 2, and let's say this is my plane 1. Okay, plane 2 equation is r dot 1 minus 1 3 equal to 5, and plane 1 equation. Plane 1 equation over here will be r dot 1 minus 1 3 equal to 11. Okay, take note, to find the distance between planes, we have to make sure that the planes are parallel. If not, that doesn't make sense for me to find that distance. If only they are parallel, then there will be a constant distance between these two parallel planes. Okay, so the first concept obviously is something that we have already learned. Okay, so what I'm going to do is I'm just going to let a point A be here. Okay, let's say point A here to be 500. Okay, essentially to find the distance between two parallel planes, it's like finding the shortest distance from a point to a plane. Okay, we have already learned that in the previous video. So if you don't remember how to do it, do go and check back on the video that focuses on finding the distance from a point to a plane. Okay, so we just need to let a point on plane 2 or plane 1 also can. Okay, then we just find the shortest distance from a point to a plane. Okay, essentially this will help me to derive the distance between two parallel planes. That's method 1. Okay, now method 2. Okay, I'm not going to just do all the working. You can then try it out yourself. You should be able to derive. Okay, method 2 essentially is using the distance from plane to origin. Okay, from origin to plane 2, let's say. Okay, you should derive as 5 over, let's see, it will be modulus n will be 1 square plus 3 square will be root 11. Okay, distance from origin to plane 2, plane 1 over here. Sorry, I realized there's a mix up over here, my bad. Okay, this is plane 1, this is plane 2. Okay, so distance from plane origin to plane, this is plane 1, my bad. Okay, I hope you are still following me. Okay, distance from origin to plane 2, okay, to plane 1 to plane 2 will then be 11 over root 11. Okay, so assuming my origin is here. Okay, so distance from plane 1 to origin will be 5 over root 11. Okay, distance from plane 2 to origin will then be 11 over root 11. So to find the distance between plane 1 and plane 2 essentially is distance between plane 1 and plane 2 will then be the furthest away one, which is root 11 over root 11 minus away 5 over root 11 to give me 6 over root 11. Okay, now take note. Okay, then what I'm going to learn is essentially to find the distance between two parallel planes is actually this formula over here. Okay, distance between two parallel planes. Okay, say plane 1 is r dot n equal to d1, plane 2 is r dot n equal to d2. Okay, take note, d1, d2 is just the constant. You need to make sure that the normal is the same first. Okay, if the normal is not the same, you have to change the normal to the same. Okay, if not, you won't be able to use this formula. Okay, it's essentially the formula is modulus of d1 minus d2 over modulus of n. Okay, take note, this is the formula that we are looking at. Okay, so some students will start to ask me, what happened, right? What happened if, let's say, now we are assuming that origin lies on top of plane 1 and plane 2. What happens if we say origin is at the center of plane 1 and plane 2? Then what do? Do we plus them? Or how do I know which plane is actually further away? Okay, further away is still quite logic. You still can use the distance between plane origin to plane. Okay, how about if the origin is the center? Do I really have the case where origin is the center? Yes. Okay, however, take note, because if the origin is at the center between the two planes, okay, one of the constant will be a negative value. Okay, that's why we actually mod the formula over here. Okay, you realize that the model is over here. So even if let's say the origin is at center, one of the constant will be negative, so it will be minus minus to derive as positive. So there's no need for you to go and worry where does the origin lies in. Okay, just have to employ this formula straight. Okay, this formula is very useful in a way that there's a lot of application kind of questions that we are looking at that actually require you to use this formula. Okay, however, this formula is really limited in a way that I can only use this for distance between two parallel plates. No other concepts I can use this formula. Okay, so it's a very limited kind of concept. So it's not easy for you to keep this in check. Okay, but it's always good for you to remember in a way. Okay, if you really are a student that, or really are a student that someone that I always die also cannot remember the formula. Okay, then I might suggest you to revert back to the first step, the first method that we use. Okay, let a point that lies on plane 1 or let a point lies on plane 2, then I find the shortest distance between the point to the next plane. Okay, that will perhaps help you to still find the distance between two planes. Okay, so that's all for vector 3. I hope you should be able to derive this quickly. Okay, so like I say, every time you finish your vectors, if you're relearning this topic again, please do go ahead and do up your tutorial. If you are just learning certain specific concept, hope you should be able to use this concept to solve any questions that you're trying to solve. Okay, if not, that's all for vector 3. Take note, from vector 1 to 3, there's a lot of formulas, there's a lot of concept being used, but I did teach you all the vector triangle and stuff. Hopefully this will help you to trigger some memory and help you to remember a lot of things a lot better. Okay, so generally I will always suggest my students, please go ahead and do your summary notes if you can, because vector is a very huge topic, a lot of formulas out there, relationship between two lines, two planes, so and so forth. These are the things that students generally very hard to remember. So a summary notes will always help you, assist you in helping you to remember. At the same time, when you do questions, certain concepts that you are totally don't remember, you can always flip back to your summary notes and take a look instead of flipping through pages and pages of lecture notes or pages of notes that are actually given to you. So summary notes always work better in a way, but of course it's up to your individual learning to see what kind of learning situation suit you. So I'm gonna leave it up to you. Okay, if not, that's all for vectors. I hope you do understand all the concepts as well. If you don't remember, if you're a student of mine, feel free to reach out to me. There's a lot of things that we can discuss as well.